Good evening. Today we will see how to resolve this engineering mechanics problem. So this is from last year analyst question paper. So this is it will come under the category of forces in three-dimensional planes. So the three cables are connected at A where the forces P and Q are applied as shown in figure. Q they are given as a 0. P is what we have to find, and tension in cable AD is given as a 305. So the first thing we have to do is marking all the points coordinates. So it is clearly given as a 0 O as a 0 point, and x y z are given. So based on that we can mark each point. For example, you mark point A, which is x it is 960, y direction it's 240, and z direction it is on the axis, so it is 0. So if you take in a three-dimensional graph, there are 2 points. Suppose if it is P1, which is x1, y1 is z1, and P2, x2, y2 is z2, then the distance between 2 points is equal to x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. Taking the square root of that, you will get the distance between the points. It's a mathematical formula. So the same way we find out the length AD, similar formula, and length of the cable AC and length of the cable AB. So we find all the lengths of these cables. Now we go to the formula which we have used in the previous same kind of a formula, previous equation what we have used. Force effector can be divided like magnitude multiplied by unit vector. The unit vector is AB. So here you see the point A coordinate B, C, D what we have marked earlier. From that, suppose if you want to find out AB, so B minus A. That's why this is 0 minus 960I, 0 minus 240J, 380 minus 0, 380K. Same way you can write for AC and AD. So we know that tension in the cable AD is 305 Newton, and TAB vector is equal to TAB scalar multiplied by unit vector of AB. So when we use it, we get we are actually grouping here I, j, k later on. Here we have written as it is the vectors. So this is the vector. If you divide each of this 960, 240, 380 by 1060, you get this value. So sum of all this is also 0, and individually I, j, k unit vector is also 0. So when we make it for I, we also add P because the P is acting in the x direction, which is in the I unit vector. So we add a P also and making it 0. So when you apply AD is 305 Newton, you get one equation. Same way when you take a K vector which is along the Z axis, you get this equation. So when you take in J vector sum, you get another equation. So when you equal both the TABs, you get resolving the equation, we get TAD equal to 305 Newton. So applying that in this one, we also get TS equal to 350 Newton. Sorry, 305 is already given. When you apply that, you will get 350, and TAB will get 450 after resolving these equations. So taking both of these things, we can find the J vector where we have seen the P value. So when you put all the known values, we get the unknown P, which is 961 Newton. So this is how we find the value of P. So while doing this sum, we have to be a little careful to avoid miss any forces. Otherwise, it will consume a lot of time to correct the mistakes during in the exam hall. Thank you.